So this is question 16, higher paper 1, 2012. We're asked to differentiate y equals 3 lots of cos to the 4x. So a little talk about cos to the 4x first of all. This is exactly the same as cos x raised to the power 4. That's what it means. The reason we don't write cos x to the power 4 is there'd be confusion. Does this mean the cosine of the angle x to the power 4, or does it mean cos x all raised to the power 4? That's confusing. So we tend to slip the power in there, which means that the whole of cos x is being raised to the power 4. And that's what it would be with the 4 at the end. We do need the brackets there, though, to avoid confusion. So we're basically looking at something raised to the power 4. Now, what you have known up until now is that if you're differentiating x to the power 4, the index comes down to the front, and then you take 1 away from the index. So x to the power 4 differentiated would give you 4x cubed. We've not got x to the power 4. We have something to the power 4, and this something happens to be cos x. So there's a little formula in x, or function of x, that's being raised to the power 4. So we do this rule that we already knew, but we make an adjustment. And the adjustment comes from looking at the thing that's, if you like, masquerading as an x. What's pretending to be an x? Well, it's cos x, and we differentiate it. Now, that is the chain rule in this particular example, where we've got something raised to the power 4. So normal rule, 4 times that something cubed times what you get when you differentiate that something. So that's the adjustment that's made. So here we go, dy by dx will be equal to, the 4 comes down the front, well, there's a 3 there, so it's 4 times 3. 12 times this something, which is cos x, to the power 3, times whatever we get when we differentiate cos x. Now, what do we get when we differentiate cos x? Well, I either look up the tables, or you think about the cosine graph. The cosine graph, because remember, differentiating is finding gradients, and the cosine graph starts off downhill, so we know there's a negative involved, and cos changes to sine. So what we get when we differentiate cos x is negative. I'm just drawing the cosine graph to remind you that there's a negative in there. The cosine graph, when we differentiate it to find the gradient, has a negative slope. So that's the negative sine x. You can look that up in your formula sheet, but differentiating cos x gives you negative sine x. So let's go back over it. Something raised to the power 4. The something happens to be cos x. So normal differentiation rule, power comes down the front, there's a 3 there, so you multiply that to the power, take 1 away, 3, times whatever you get when you differentiate the thing that's pretending to be an x, which is cos x. So here we go, the whole thing's going to be negative, that's positive, positive times negative, negative 12, cos x raised to the power 3 is normally written as cos cubed x, and times sine x. So there we are, negative 12 cos cubed x sine x. And let's now see what the choices are, so we can choose the correct one. There it is, negative 12 cos cubed x sine x, which is choice C.